Hello friends, welcome to Crackgate CSE, and in this series of computer organization and architecture, today we'll be understanding what is system bus design. That means what kind of different buses that we have in our system, what is the role of each individual bus, how it carries the data or the address, and what are the limitations to these system bus and how we can resolve these limitations by introducing some bus configurations. So we'll be understanding everything in detail. Later on we'll also be solving one question on the basis of the bus configuration. So please watch this complete video. This video will be very helpful for you in understanding the concept and building the concept which will be used in the topics that we are about to study later in this particular playlist. So without wasting time, let's start with the system bus design. So first of all, we know that what is bus. What is the role of bus? Bus is used to carry the passenger from one end to another end. Similarly, if we talk this bus with respect to the system, bus carries the information from the system from one component to another component. So the role of bus is same, but the characteristics of these buses will be changed with respect to the system. So bus is a communication channel. Characteristics of bus is shared transmission media. Why we are saying that the characteristics is shared transmission media? Because these buses will be shared with the different components of a computer. A particular bus will be connected to the CPU and as well as memory and to the IO as well. So a single bus is shared among the different components. That's why we say that the bus is a shared transmission media, right? Now there is one limitation of the buses with respect to the system. Limitation of bus is only one transmission at a time. So in buses only one transmission at a time is allowed, because if we allow multiple transmission then there will be some conflict. For example, the CPU is sending data to memory and memory is sending the data to IO. Then there is a possible collision when this is transferring to memory and memory is transferring to IO. So to avoid such kind of collision, we allow only one transmission at a time. So a bus which is used to provide the communication among major components of a computer or a system is called a system bus. For example, let's say this is a particular system in which we are having different components like CPU, memory and IO. So the bus will be used to provide the communication with all these components so that these components can communicate with each other and perform the instructions or perform any computation whatever is required as per the scenario, right? So the bus which is used to do these kind of tasks is known as system bus. So the system bus is used to connect these three, right? Now there is one important thing that you should understand is that the CPU is the processing unit, right? So if CPU is a processing unit, it is also the fastest unit, and this CPU generally behaves as a master. That means it controls all the other components, right? Now if we talk about the memory is used for the storage and it is comparatively slow with respect to the CPU, right? And generally this memory acts as a slave because it does not execute any instruction or any operation by its own. It has been ordered by CPU to perform some task. That's why the memory is referred as a slave, right? Now in memory we are having the addresses to represent the respective cell, where the control signals play an important role that what we have to do with the cell. So this is, I'm just giving you the overview how the things are working. Similarly, if we talk about the IO, so IO is for the extended communication, that if you want to extend your communication by input or output, so the IO will be used. This is very slow. So IO is the slowest component of a system because it is slower than the memory also. And it is also usually slave, but in some special cases like interrupt or anything else, this may behave as a master. And here in IO also we are having addresses, but those addresses are called as ports. So in IO the addresses are called as ports, and here also we are having the control signals to identify the kind of operation, right? So this is a general overview of the system buses and the system. Now there are three kind of lines or buses, you can say, which are used to provide the efficient communication between CPU, memory and IO. So we are having three kind of lines and each line can be referred as a bus. So the first one is address line, second one is data lines, and third one is control lines. So the address lines are used to carry the address. See, this is the first one, address lines. So first we'll talk about the address line, then we'll talk about the data line, then we'll be moving on to the control lines. Just be with me and watch this complete video. You'll be getting each and everything in a clear manner. So what is address line? Address lines are used to carry address to memory and IO, because generally CPU generates the address request or the memory request. So CPU will be forwarding this address to either memory or IO as per their requirement. And these address lines are unidirectional in nature because only CPU can forward the address to memory and IO. These both cannot forward the address to the CPU, right? Now based on the width of address bus, whatever the width we are having for the address bus, we can find out the capacity of a memory system, right? We can determine the capacity of a memory system. For example, let us consider 8085 and 8086 microprocessor. In 8085 microprocessor, I already told you in the previous video that we are having 80 to 87 as the time multiplexed pin and A8 to A15 as the address pin. So collectively we are having 16 address lines. So if we are having 16 address line, how many cells are possible? Just find out the 2 to the power 16. So 2 to the power 16 cells are there. 2 to the power 16 is equals to 64k cells are there, and we know that in memory is byte addressable, therefore the size of cell is 8 bit, which is known as 1 byte. So finally 64 KB memory is the capacity in 8085 microprocessor. Similarly, you can find out the same for the 8086 microprocessor, because in 8086 we are having 20 address line where 0 to 15 are the time multiplexed and 16 to 19 are the simple pins. So 20 address lines are here. So if you find out 2 to the power 20, that many cells will be having. 2 to the power 20 is equals to 1 mega. So 1 mega cells are there and one cell is of 1 byte. So finally 1 MB is the capacity of the memory system which is used in 8086 microprocessor. Now let's quickly move on to the data lines. So these data lines are used to carry the binary code, which you can refer as data, because whatever the data we are having in a system is in the form of binary. So these data lines are used to carry the binary code between CPU, memory and IO. That means all the components that we are having in a system bus. These data lines are bidirectional in nature. What is the meaning of bidirectional? That means data can flow from CPU to memory and from memory to CPU as well. Similarly, from CPU to IO, IO to CPU, and memory to IO and IO to memory. So this is the meaning of bidirectional. So the data can flow in any direction because any particular component may require data for any execution. On the basis of the width of the data bus, CPU word length and performance can be determined. So if we know what is the width of the database, we can find out the CPU word length as well as we can find out the performance using the data lines. Now let us consider again this example of 8085 microprocessor. So here we know that these 8 bits are used for address as well as data. So in 8085 we are having 8 data lines, and these 8 data lines represent the 8-bit word length, right? And if we are having the 8-bit word length, we can know we know that the operations are performed in 8-bit data code. That means the CPU word length is equals to 8. Similarly, if you consider the 8086 microprocessor, here we are having 16 data lines. So these 16 data lines represent that the word length is nothing but, so here we are having 16 data lines which represent the word length is as 16-bit. That means operations are performed on a 16-bit data code. Similarly, you can find out on any microprocessor. Right, now let's quickly move on to the control lines. So these control lines are used to carry the control signal. What are the control signal? Control signal let us know that what kind of operation need to be executed. So these control lines carry the control signal as well as the timing signal, right? So the control signal indicates the operation, the type of operation. So this is not time, this is type of operation, right? And this timing signal is used to synchronize the memory and the IO operation with CPU clock, because for the better synchronization the CPU clock or the time has to be same in all the components, because if the CPU clock differs then there is a synchronization because of which there will be some conflicts. So it's better to synchronize. So this is a there is a topic in distributed operating system like synchronization, or in general operating system also there is a topic of synchronization. So there is a strong relationship between computer organization and operating system, both relies on each other. So this topic is there in operating system, we will be discussing over there also. For now you can understand that if the time between the memory, IO and CPU differs, there may be some problems, because of which synchronization is important, and the timing signal informs the CPU clock to all other components, right? So we understood what is address line or the address bus, what is data lines or the data bus, and what is control lines and the control bus. Now there is a special case under which an ambiguity is possible. So now we have to understand what kind of ambiguity can be there. So this is a special case. So when there is a common bus, common control signal and common address bus. So when common bus, common control signal and common address space is used between memory and IO, then there is a possibility of ambiguity. So I'm taking an example to explain that ambiguity. So let the CPU is generating a memory request as 1000 RD. Right, so let me just keep it here for a while so that you can easily watch what is going on. So here we are having these three components, and the CPU is generating a request to access the location 1000 and to read that data. Now we are converting this particular instruction into our readable form, and we are transferring it to the common address space. Because we are having common address space and common control signal and common bus, we will be sending this particular memory request to the bus, and this bus will go to the memory controller, which will be controlling the memory and validating the request. Similarly, there is an IO controller, and that bus is also connected to the IO. So the IO controller will also check for the validity of that request. Now this 1000 is already present in this memory. Let's say that there is a address which is having the 1000. So there is a cell which is having the address as 1000, and we know that in memory there are two control signals, read and write. So this 1000 location is also valid, and this particular control signal is also valid. And if we move on to the IO controller check that yes, there is a port whose address is 1000. So in that case that port address is valid. Similarly, read, which is a control signal, is also valid. So here you can see that the CPU is generating the memory request, but it is getting forwarded to the memory as well as IO, and at the both of the places it is valid. So there is an ambiguity. So to handle these kind of ambiguities, several bus configurations are used. So three such bus configurations are IOP, which is input output processor. Second one is isolated IO, which is IO mapped IO, and third one is memory mapped IO. So we'll be understanding each of these one by one. So first of all, let's move on to the IOP, which is input output processor. This configuration uses the common bus and common address space. So common control signal and common address space is used, but different buses in both memory and IO. So to avoid the conflict, we are using the different buses, and this kind of design is expensive, and it is generally used in generally suitable for supercomputers to perform the simultaneous operations, because in supercomputer we have to perform multiple operations at a time, like parallel processing, right? So we use this kind of design in the supercomputer as they are very expensive. Now let's move on to the second one, which is isolated IO. So the isolated IO uses the common bus, common address space, but different control signals, because the problem was arising when we are having common bus, common control signal and common address space. So we have to change one thing. So here we are taking different control signal and common bus and common address space for both memory and IO. So this particular kind of configuration is comparatively less expensive, and here we use a special pin which is IO/M bar pin. IO represents the input output component and M represents the memory component. So it is used to activate the respective component. So we will be using this special pin for the implementation, and these kind of design are used in general purpose computer design. Now let's try to understand with the help of some control signals and the table. So here I am having one table and the control signals which will be helping you in understanding. So just let me put this paper over here so that you can just visualize at the same time. So this is what I explained you. So here you can see that we are having different control signal. I told you that we are having different control signal. So for memory the control signal is different, and for the IO the control signal is different. Now in memory we are having two control signal. One is to read, another one is to write, which is named as memory read and memory write. And this bar on it shows that it is a active low pins, right? So this one is said as load to store, or you can refer it as read or write. Both are the same thing. In IO there is one IO read, IO write with a bar. So this is represented as in or out. So these are same as read and write. This is, we are just dividing and giving them the different names so that there is no confusion. Now you can try to understand this particular table. So this particular table explains everything about this kind of about this isolated IO configuration. So this IO/M bar is a special pin which tells you whether we are working on the memory or we are working on the IO. So this M is an active low pin. So if this is 0, that means the memory is activated. That means the operation is performed on memory. So both the 0 values, you can see that we are working on the memories, and for both the 1, this M will be disabled and this IO will be enabled because this is active high pin. So for 1 we are working on IO. So if read is 0, it will be enabled because of active low pin. Similarly, if write is 0, it will be enabled. In IO, if read is 0, read will be enabled, and if write is 0, write will be enabled. So this is a table to understand which particular component is enabled and what is the control signals that we are using. Now let's move on to the memory mapped IO. So the memory mapped IO configuration uses the common bus and common control signal but different address space. So now we are using different address space for memory and IO. And in this design, the memory address space is shared to IO ports. That means we are taking some cells from the memory and we are allotting these cells to the IO, right? So the limitation is we are not able to completely utilize the memory address space because we are allotting some of the cells of the memory to the IO, right? For example, you can understand that we are having a 2-bit address, and here is a decoder to decode this address into this respective location, right? So what it can be 00, 01, 10, 11. These are the 4 possibilities if we are having 2-bit address. Now let us say that we have to use 2 ports in IO component, input output component. So what we have to do is we have to allot any 2 cell of this memory to the IO. So what we are doing, we are allotting cell 2 and cell 3, like this one and this one, to port 0 and port 1. And if we are allotting these 2 cells to the memory, so the cell 2 and cell 3 will be disabled, so that if there is any request from the CPU, we will say that this is not available in the memory because we have allotted them to the IO. So here you can see that we are having 10, 00, 01 and 11. And this 10 and 11 is disabled and allotted to the IO port address, right? So this is how it works. Now let's quickly try to understand one example based on this memory mapped IO. So the question says that consider 24-bit processor which supports 256 KB memory address space. So how much memory address space is here? 256 KB, and KB shows that the memory is byte addressable because of this B, right? Similarly, we are having 24-bit process. That means the word length is 24-bit. Now the processor uses the memory mapped IO, in which when 2 MSB bit of address is 0, then assign them to IO ports. Similarly like this. So here we are using the memory mapped IO, where the condition is given that if 2 MSB bits of the address is 0, then we have to assign them to the IO. And then they are asking how many port address and how many memory address are possible in a system. So we are having 256 KB memory. So how many cells are there? 256 cells are there. So if we are having 256 K cells, then we can easily find out how many address bits are required. Just what we have to do, just find out the log of 256 K. So the log base is 2. This K is 2 to the power 10. This 256 2 to the power 8. So we can clearly say that 18 address bits are required. Right? So 18 address bits are required. And out of these 18 bits, the condition is given that if 2 MSB bits of address is 0. So let us say that I am having the pins as AD0 to 16, AD16, right? AD17 and A18, right? Because 18 address, so here I am having 16 and these two are 18. We have to talk about the 2 MSB bits. So MSB bit are on the left hand side. So let's talk about these two bits. So what is the possibility of these two bits? Either both will be 0 or 0 1 or 1 0 and 1 1. So only 4 possibilities are there, and in only one case the 2 MSB bits are 0. So for this one case, how many possibilities are there? These 16 bits, that means 2 to the power 16. These many port address are possible, right? Similarly, these will be for the memory address. That means 3 into 2 to the power 16 are the memory address are possible, right? So this is how you can answer such type of questions, right? So because there is 16 2 to the power 16 possibility for 0 0, and for these three values also 2 to the power 16 possibility. So here I am multiplying with 1, that will be our port address as per the condition, and if we multiply by 3, that will be our memory address. So this is how you can find out these kind of questions. I hope that you find this particular video useful, and in case if you are new to this particular channel, please subscribe this channel, and if you are able to learn something new from this particular video, please like this video and share it with your friends. And please do not forget to mention your comments in your feedback, because your comments and likes really motivates me to bring more such videos for you all. Thank you very much for your time. Keep supporting, keep learning. Have a great day.